Good morning, this is Yashaswini Razdan reporting for E-Times. I'm here at Electronica, Bangalore, and I'm sitting with Mr. T.R. Shashwath, who is the co-founder of Mindgrove Technologies. You have ventured out into this highly competitive market, and you've chosen to build mid-range SoCs.
Yep.
So, who are you exactly targeting with these? Because there's so many players out there doing the same thing. So,
Yeah.
how do you intend to crack this market?
So what we found is that uh, there are a large number of players, but the market opportunity is larger than anybody is able to uh, fulfill on their own. So there are niches where people want something slightly different, and that 10% of difference is where you need to differentiate yourself, and that is where a lot of the magic happens.
Okay. But how commercially viable is this approach?
It is commercially viable as long as you can make that 10% into a design problem, wherein you collate 10% from here, 10% from here, 10% from here, find the commonality and solve for the commonality, create something which is saleable in a very large volume. Ultimately, volumes make the difference. Uh, but and so if you try to customize, we found that the cost of customization will be borne by the customer, and that is just not a viable option. So, my job as a designer is to find a way to bridge the gap between all of these last mile 10%, bring them to the common place, and then it becomes a viable option for somebody. Because I am now amortizing the cost over like several players.
Technologically, how do you differentiate yourself from established players?
One of the first things is we don't try to differentiate ourselves technologically in that sense. Like there is no different, like, I mean, these are microcontrollers, right? And microprocessors.
Yes.
How many different kinds of UARTs are there in the world? There is, yeah. So you can't really differentiate in terms of the, somebody may have three, somebody may have five. That's not the differentiation.
Okay.
How the insight which leads us to differentiate is that um, the way that the customer interacts with the chip
Okay.
is either by designing a board around it or writing software for it.
Okay.
The way that there is a third way in which a company interacts with a company making chips, which is through the supply chain. And so our differentiator, especially for the mid-range, small-range kind of players that whom we want to target, is the experience over here of using our chips. So starting from from saying that I will pick up the phone and take your call, to I will give you uh, I'll give you help in getting the product out. I'll give you reference designs. I will give you various forms of hardware help. I'll give you various forms of software help from an IDE down, reference programs, IDs, everything. Um, we made some modules ourselves. We will work with partners to make further modules so that our customers can hit the road running. And a lot of this, it's the ecosystem which is actually what will differentiate any player, frankly. I don't see a technological differentiation as something that can uh, really move the needle, especially when there are so many established players in the market.
So you yourself acknowledge that there are established players.
Yeah.
So what is your long-term survival strategy plan?
There are two or three things. There are niches
Yes.
which established players will never touch, but which are significant for a smaller, medium-sized company, or for a smaller, medium-sized division in a bigger company. However you want to look at it, right? It's the same thing. And we try to target those kind of people.
Okay.
Those niches can be very long-term survival. The second, there is a lot of luck involved. You have to acknowledge that now, being the industry that we are. But the third is we are also going after the kind of industries where the commitments are long term and the relationships are very long term. And once somebody qualifies a product, they really don't like to move around. And the other part of it is it's very contingent, of course. It's not something that I can recommend to everybody and say replicate this, but sitting where we are and sitting in the opportunities that we see go in front of our eyes. If you can qualify yourself to an industry which is moving up, which wants to change,
Yes.
and which historically or by their constitution don't change very often, you're sitting there for 10-15 years. So
Okay.
that is one major survival strategy. That's survival, and that is long-term base rate. After that, we have to see what opportunities open up. The world is moving so fast. I don't want to predict anything, though we have some ideas. I don't want to predict anything now. We will be seeing a lot of changes, and the other part of it is to build up a lot of fundamental technology, so that we are nimble and agile enough to respond to those changes as they are happening in real time.
Moving to RISC-V.
Yeah.
RISC-V is your core, where you started from. Your origins are from
Yeah.
Shakti, IIT Madras. So, how do you see RISC-V adoption growing in the frame that you are working, mid-range chips, and across the years, across different sectors, be it consumer
Yeah.
electronics, IoT?
See, nobody buys a RISC-V chip or an ARM chip or a, people do buy Intel chips, but then that's an integrated ISA.
Yes.
But nobody buys it because it's a RISC-V or an ARM. They buy it because it solves a problem,
Okay.
right? And I would say, if you're looking at a mobile kind of a chip, it's not easy to build that up. It requires a lot of capital, and that's the limiting factor over there. But if you're looking at the embedded, the mid-range, the small range, I think it's already happening. A lot of, for example, Espressif, ESP32s, a lot of them are already RISC-V.
Yes.
A very large, I don't know if it is the majority yet, but it's definitely growing. And the toolchain is identical. It's GCC, it's LLVM, it's the same IDs that we are using. It's the same, almost everything is imported. We have been running Linux on RISC-V all throughout. So that I don't think those are barriers to entry, frankly. The big players may or may not adopt, but I do see a lot of smaller companies, smaller SoC companies moving to RISC-V. One is for the cost advantage. Of course, everybody is going to keep talking about that, but then I have a different perspective. I said earlier about being nimble and agile.
Yes.
And the fact that it is an open ISA, and the fact that we are using Shakti,
Yes.
which is open source itself. It's an open source microarchitecture.
Yes.
More importantly, it's a microarchitecture we understand. We keep playing with it. We keep making changes to it.
I can
And-
see that. I can see that with the Pac-Man game. over
Yeah,
here.
that was really amazing. I didn't even know they were going to achieve that, right?
And they used a random number generator.
Yeah, that is still SoC, but
Yes.
even then, in the next series, we played a lot with the pipeline, with the code pipeline itself. Tweaked it this way, that way, pushed performance, pulled down power, reduced area, increased something else, whatever. We get a lot of flexibility to play with it, and that contributes to agility. So when somebody comes to us, a customer comes to us and says, I'm having this problem. Between here and here, I'm facing this particular latency. And if you solve it, I will buy. We can go back and say, hey, you know what, we can actually take this up at the core level, or we can take this up at the SOC level, we can take this up at the board level. Or we can have a part of a solution which is at the board, and the other part, I will just make a tweak in the code pipeline which will speed up that one particular pathway.
Okay.
Now that is it's a superpower.
Alright. Moving on to the ecosystem, have you built a broader ecosystem around your SOCs with tools, development kits?
Building, always building.
Mm.
We have a few partners whom we will announce very soon.
Okay.
Negotiations, last few negotiations are going on.
Okay.
Lots of people are very interested in taking it up to build SOMs. We showed the way with the first SOM that we designed. I think you saw that.
Yes.
And I'm really proud of that also, because that reduces the friction to adoption so much for a customer. I used to love working with SOMs.
Okay.
And so the second part of it is software. A lot of people are building. There is, of course, we give a very complete IDE and toolchain, but a lot of people have expressed interest in building their own versions of it, their own flavors. And apart from that, the larger RISC-V ecosystem already exists with a lot of things that have already been built. I'm very happy with Zephyr as an RTOS, for example. I'm very happy with a lot of the other things that have gone through. So, yeah, we are building the ecosystem always. I'm always looking for more people to build ecosystem with.
How do you convince, in all your engagements with customers, how do you convince them for, adopting a chip, made in India chip, made on a RISC-V core? What kind of have you noticed an initial resistance and that hesitation, and how do you counter that?
Do I notice resistance? There was a lot of resistance to begin with, yes. That's come down a bit because, and I have to thank the government for a lot of support, material and immaterial. Just sharing just saying that there are Indian chips from an official line has helped. It may sound funny, but then it helps. It helps raise awareness. It helps people accept that, okay, if I buy this, at least I will not. Somebody in the government will not come and yell at me. The second part of it is that we have also grown as a company, and we've changed a lot in the way that we approach a customer. And it's not just about selling a chip, right? It's about solving a problem. It's always about solving a problem for your customer. So we go to them and we ask them what is their problem. Why are they looking for a change?
Okay.
Otherwise, why are they talking to us, right? So why are they looking for a change? What is it about their current solution which it could be a cost, or it could be a feature that they're not able to adopt. It could be a supply chain issue. And we work with them to solve those problems. And we work with them to build a proof of concept. It's a longer thing. It's about relationship building. And once you start building those relationships, then the resistance naturally drops. I mean, they're buying a TI chip or an NXV chip or a Mindgrove chip. They're not buying a RISC-V chip. They're buying a chip because it solves their problems. So, solve their problems effectively and they do come.
Moving on, last year you announced Secure IoT with huge fanfare.
Yeah.
What is next that the world can expect from you?
Number one, Secure IoT will be available on shelves.
Okay.
That has taken us a long time to get it done.
Okay.
All kinds of interesting twists and turns, I will put it that way.
Okay.
But finally, from prototype launch to production,
Yes.
we are in the last lap of that. So that will be out very soon.
Okay.
The second is that we are building Vision, which is the second family.
Okay.
And we will be announcing the exact product lineup soon. That is going into internal prototyping right now. So next year we will hopefully have chips out which people can at least get their hands on.
So will these vision chips be used in all of this hullabaloo going around about security cameras,
Yes.
STQC certifications. Will it be STQC certified?
So the way STQC certification for cameras works is that it's not a chip certification, it's a whole module certification.
Yes.
But for the customer, what we do is we pre-run all of the certification so that as of now, I think there are some 36 criteria in STQC certification, and I'm very happy to say that we meet all 36. We have a path to help the customer meet all 36 off the bat.
Okay.
So actually, Secure IoT meets 35 out of 36 already.
Oh.
So we just use the whole thing.
Okay. Well then,
Yeah.
I really wish the very best of